Types and construction. Boilers. A boiler is a closed metal container or vessel in which water is heated to produce steam or heated water. Steam or heated water is then used to heat buildings or used in a variety of industrial processes. To produce steam, water must be heated to at least 212 degrees Fahrenheit and converted to a gas. Boiler design. Boilers are designed and manufactured for specific purposes and are unique in design, maximum allowable working pressure, boiler horsepower, application, fuel, and fabrication location. Boilers are commonly classified by design as fire tube boilers or water tube boilers. In fire tube boilers, heat and gases of combustion pass through tubes surrounded by water. In water tube boilers, water passes through tubes surrounded by gases of combustion. Maximum allowable working pressure. Maximum allowable working pressure, or MAWP, is the recommended maximum pressure in pounds per square inch, or PSI, at which a boiler can safely be operated. MAWP is determined by the design and construction of the boiler in accordance with the American Society of Mechanical Engineers, or ASME, code. The ASME code regulates the types of material and methods of boiler construction. Boilers, fittings, and accessories are identified with the official ASME code symbol stamp. ASME code symbol stamps use letters to identify boiler components. For example, the ASME symbol stamp for a safety valve is a letter V. The stamp is included on the data plate of the safety valve. Boilers are classified as low-pressure boilers or high-pressure boilers depending on the MAWP. Low-pressure boilers have an MAWP of up to 15 psi. The MAWP for low-pressure boilers may vary in some states and should be verified with local authorities. Low-pressure boilers are primarily used for heating buildings such as schools, apartments, warehouses, factories, and for heating domestic water. High-pressure boilers are commonly used for process loads, with an MAWP ranging from 75 to 700 psi. They have an MAWP above 15 psi and over 6 boiler horsepower. A boiler horsepower is the evaporation of 34.5 pounds of water per hour from and at a feed water temperature of 212 degrees Fahrenheit. 1 pound of water is required to produce 1 pound of steam. A boiler horsepower is also defined as 33,472 BTUs per hour. Applications. Hot water produced in a boiler is primarily used for heating applications, supplying water to the system at 160 to 220 degrees Fahrenheit. Steam is used for heating or process applications. Process applications pertain to industrial processes requiring steam. Fuels. Fuels commonly used to generate heat to produce steam in a boiler are fossil fuels taken from the ground. These include coal, fuel oil, and natural gas. Fuels are rated by heating value. Heating value is the number of BTUs per unit of fuel. A BTU is the quantity of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. The heating value of coal is expressed in BTUs per pound. The heating value of fuel oil is expressed in BTUs per gallon. The heating value of natural gas is expressed in therms. A therm has 100,000 BTUs. Electric boilers operate similarly to boilers fired by fossil fuels, but produce heat by electric resistance coils or by electrodes. Electric boilers are 100% emission-free and are used as an alternative where fossil fuel combustion and the handling of combustion byproducts are unacceptable. Fabrication location. Boilers are available as package boilers or field-erected boilers. Package boilers are pre-assembled at the factory. All components for hookup and operation are in place. The package boiler is a self-contained unit complete with feed water regulator, burner assembly, and combustion controls. At the installation site, package boilers only require connections of feed water lines, steam lines, fuel lines, and connections to breeching and chimney. Package boilers originated with the Cleaver Brooks Company over 60 years ago and have steadily grown in popularity. Package boilers can be either a fire tube or water tube design. Field-erected boilers are constructed on-site at the point of use. These large-capacity boilers are used when load requirements exceed the capacity of package boilers. Field-erected boilers often reach as high as 6 stories. Field-erected boilers, like package boilers, must be inspected and must comply with all applicable codes and standards. Fire tube boilers. In a fire tube boiler, the furnace and tubes are surrounded by water and steam contained within a closed vessel. Heat from the flame and gases of combustion pass through the tubes while the water surrounds the tubes. The tubes increase the amount of heating surface in contact with the water in the boiler. Heating surface is the surface in which heat from the gases of combustion is transferred to the water in the boiler. A larger heating surface results in more heat transferred to produce increased water circulation and faster formation of steam bubbles. This results in greater thermal efficiency of the boiler. The gases of combustion in the tubes make 2, 3, or 4 passes depending on the design. A pass is the area where gases of combustion travel the length of the boiler. The more passes, the greater amount of heat transferred to the water in the boiler. Tubes in a fire tube boiler are measured by the diameter of the tube in contact with water in the boiler, or outside diameter. Fire tube boilers are high or low pressure boilers and contain a large amount of water. Because of their vessel size, fire tube boilers can respond to load changes with minimum variation in steam pressure. Fire tube boilers are available as either dryback or wetback boilers. In a dryback boiler, a refractory lined chamber outside of the vessel directs the gases of combustion from the furnace to the tubes. In a wetback fire tube boiler, a water-cooled turnaround chamber directs gases of combustion from the furnace to the tube bank. A tube bank is an assembly of tubes in the boiler. Fire tube boilers are used for hot water and low and high pressure steam for heating and process applications. Steam pressure in a fire tube boiler is generally limited to approximately 350 psig and 800 horsepower. PSIG is the pressure indicated on the steam pressure gauge of the operating boiler. If greater pressures and horsepower are required, a water tube boiler is generally used. Vertical fire tube boilers. Vertical fire tube boilers are one-pass boilers with the combustion chamber or firebox on the bottom of the boiler. The firebox is supported by stay bolts with a water leg formed between the inner and outer wrapper sheets. Heat is transferred from the vertical fire tubes in the water leg. Firebox boilers. The firebox boiler is similar to a fire tube boiler. However, the combustion chamber has flat sides rather than the cylindrical shape of the fire tube boiler. This compact design provides high outputs in a smaller space than a fire tube boiler. The firebox boiler has water legs supported by stay bolts which extend down the sides of the boiler. The stay bolts prevent the sides from bulging from pressure in the boiler. Firebox boilers are used for low-pressure steam or hot water heating applications. Sizes of the firebox boiler range from 12 to 337 horsepower and are package boilers. Horizontal return tubular boilers. Horizontal return tubular, or HRT boilers, consist of a fire tube boiler suspended over a firebox or furnace. The drum is supported over the furnace by slings or lugs mounted on the drum, which rest on the brick setting. Gases of combustion are directed from the furnace under the drum through the tubes secured into the front and rear tube sheets. Baffles in the furnace direct the flow of gases of combustion for the greatest efficiency. Tube sheets are secured to the drum using diagonal stays or through stays. The stays provide support to the tube sheets in areas not supported by the tubes. In water tube boilers, water passes through tubes surrounded by heat from the flame and gases of combustion. The heat is transferred to the water in the tubes. Baffles direct the gases of combustion for multiple passes to obtain maximum efficiency. Water tube boilers were developed to meet the demand for higher steam pressures than could be produced in fire tube boilers. Fire tube boilers, to obtain comparable pressures, would require thicknesses which are not practical. Water tube boilers can be classified into industrial or commercial water tube boilers. Industrial water tube boilers. Industrial water tube boilers produce steam or hot water for industrial process applications. An industrial water tube boiler consists of multiple drums. A steam drum, or drums, is located above the mud drum, or drums. The steam drum and mud drum are connected by tubes. Gases of combustion are directed by baffles around the tubes. Water in the tubes is heated and rises to the steam and water drum where steam is released. Cooler water descends through downcomers to the mud drum. Industrial water tube boilers are noted for their fast steaming capability, as there is less water to heat than a fire tube boiler. The low water content allows fast response to changing load demands. They are used for high-temperature hot water and high-pressure steam process applications. They are rated in pounds of steam per hour at operating conditions and range from 10,000 to 134,000 pounds per hour. Commercial water tube boilers. Commercial water tube boilers produce steam or hot water for commercial or modest-size applications. Commercial water tube boilers include bent tube, straight tube, and membrane boilers. Bent tube water tube boilers. Bent tube water tube boilers are used for low-pressure steam or hot water applications. Baffles direct gases of combustion for multiple passes around shaped tubes. Bent tube water tube boilers use fossil fuels and are available in sizes ranging from 2 to 9 therms per hour input and up to 250 horsepower. Bent tube water tube boilers are commonly used in heating applications using low-pressure steam or hot water because of their resistance to thermal shock. Straight tube water tube boilers. Straight tube water tube boilers operate similarly to bent tube water tube boilers. Straight tube boilers have straight tubes that are surrounded by gases of combustion. Steam and water enter through an internal feedwater line. Membrane water tube boilers. Membrane water tube boilers are compact boilers used where space is limited. The vessel of membrane water tube boilers consists of formed membrane tubes and downcomers connected to upper and lower drums. The boiler vessel is gas-tight, insulated on the outside, and covered by casing constructed of removable formed steel. Membrane water tube boilers are package boilers and range in size from 34 to 250 horsepower. They can be used for hot water or low or high pressure steam for heating or process applications. Cast iron boilers. Cast iron boilers operate similarly to water tube boilers, but they do not have water tubes. The flame and gases of combustion are directed through cast iron sections of the boiler. The cast iron sections, similar to tubes, act as vessels which contain water. The water is heated in the sections and converted to steam. Because each section is modular, additional sections can be added to increase capacity as required. Cast iron boilers are limited to low-pressure steam or hot water for heating and process applications and typically range in size from 25 to 200 horsepower. Review. A boiler is a closed metal container or vessel in which water is heated to produce steam or heated water. Boilers are commonly classified by design as fire tube boilers and water tube boilers. In fire tube boilers, heat and gases of combustion pass through tubes surrounded by water. In water tube boilers, water passes through tubes surrounded by gases of combustion. Boilers, fittings, and accessories are manufactured in accordance with the ASME code. Maximum allowable working pressure, or MAWP, is the recommended maximum pressure in pounds per square inch, or PSI, at which a boiler can safely be operated. Low-pressure boilers have an MAWP of up to 15 PSI. High-pressure boilers have an MAWP above 15 PSI and over 6 boiler horsepower. A boiler horsepower is the evaporation of 34.5 pounds of water per hour from and at a feed water temperature of 212 degrees Fahrenheit. Fuels commonly used to generate heat to produce steam in a boiler include coal, fuel oil, and natural gas. This videotape depicts boiler operation procedures commonly practiced in industry. Boiler operation procedures vary from plant to plant. For maximum safety, always refer to specific plant procedures and applicable federal, state, and local regulations.